Hi folks, we're going to take a look at number 12 from page 498. So they give us the equations of two lines, and they tell us that these two lines intersect at a point. Okay, now notice that this one here has an unknown value in the direction vector. So what they want us to do is to find that unknown value and then find the point of intersection. Okay, so the way in which we find intersections of lines is to consider them in parametric form and then solve a system of equations. So let's start by writing them out in parametric form. So x1 is equal to negative 3 plus s. Here x2 is going to be equal to, oh sorry, not x2, I mean y1, sorry about that, is equal to 8 minus s. Okay, and z1 is equal to 1 plus s. Okay, then from the second line we have x2 is equal to 1 minus 3t. y2 is 4 plus kt. So here we've got our unknown value. And then z2 is equal to 2 plus 8t. Okay, so here though, we have two unknowns, yet we have three equations. So we can only work with two equations at a time. So it makes sense to work with the two equations that don't possess the unknown value of k. So we can use that to determine our s and t value. Okay, so since we're looking for intersections, it means that this x, y, and z needs to be equal to that x, y, and z. So I just have to equate the components. So first I'll start by equating the x's. So we end up with negative 3 plus s equaling 1 minus 3t. And we also need 1 plus s to be equal to 2 plus 8t. And what that leaves us with is a system of two equations and two unknowns which I'm able to solve. Okay, so I'll do this by elimination. We'll subtract in order to eliminate the s's. So we end up with negative 3 minus 1 is negative 4. Here we got 1 minus 2 is negative 1. And negative 3 minus 8 is negative 11t. So I'll bring the 11t to the other side. So I'm left with negative 1 plus 4 is 3. And t is equal to 3 over 11. Okay, not the nicest number, but that's fine. So now that we have the t value, we can use one of the equations to find the s. And so here I think that first equation is the easiest one to use. So we have negative 3 plus s is equal to 1 minus 3 times t, which we just found to be 3 over 11. So s is equal to, this is 1 plus 3 is 4, which I'll write over 11. So that'll be 44 over 11 minus 9 over 11. So s is equal to 44 minus 10 is 34. So that'll be 35 over 11. Okay, so this is the s and t values that are going to make the first and third equations equal. Okay, but what I know is that these two lines actually intersect. So that means that this s and t value is also going to have to make the y components equal. And that's what I'm going to be able to use to solve for the k value. So I know that y1, 8 minus s, which is 35 over 11, is going to have to be equal to 4 plus kt. So 4 plus k times t, which we found to be 3 over 11. And this now allows us to solve for k. Okay, so we'll keep this together. So 3 over 11k is equal to, so I'll put everything over 11 here. So that's 88 over 11 minus 35 over 11. And we'll bring the 40 to the other side. So minus 44 over 11. Okay, so here we have, I think I'm just going to use my calculator for this. What do we have here? We have 88 minus 35 minus 44. Okay, which is 9. So we've got k is equal to 11 over 3. Okay, which I just brought over from the other side. And here we were just left with 9 over 11. So actually that turns out to be pretty nice. 11's cancel out. This reduces. So k is just equal to 3. Okay, so there's our answer for A. Okay, now we actually have to find the point of intersection. But remember, I can use either one of these lines to determine the actual point of intersection, since we've determined that they're the same. So I think actually line 1, the one that doesn't have the k, is the easiest one to use. So here, x is going to be equal to, so since I'm going to have to put in these things over 11, I'll just stick in these numbers as fractions over 11. So it's going to be negative 33 over 11 plus s, which is 35 over 11. So that one's not too bad. So we've got, that's just 2 over 11. Okay, so now let's go to the x value, which is 8 minus s. So 8 minus 35 over 11. So I should have put this over. So it's 88 over 11 minus 35 over 11. Oops, sorry, make sure you can see that. So 88 minus 30 is 58, minus 5 is 53. No, that's not right. 58, that's just use the calculator, brain's not working this morning. 88 minus 35, oh, it is 53. Okay, sorry about that. Had it right the first time. 53 over 11, and so z is now going to be equal to 1 plus s, so 1, which is 11 over 11, plus s, which is 35 over 11. So here we got 35, 45, 46. 46 over 11. So our point of intersection, okay, is equal to 2 over 11, 53 over 11, and 46 over 11. Okay, and there we have it. So just to recap, how do we find intersections of lines? We write them out in parametric form, and we equate the components. But you can only work with 2 components at a time. So you use 2 components to solve for your parameters, and then you know that that third one needs to also be equal in order for it to have a point of intersection. Okay, that's it for this one.